actually, we've got 2 more examples. So let's take a look. It says here that a model for a company's revenue is modeled by, let's use this pretty color. And revenue from selling a software package, R for revenue, is R equals negative 2.5 P squared plus 500 P, where P is the price. So the price dictates the revenue, okay? So what price will maximize? So we want the price. So we're looking for the X value for maximum of the vertex. So we're looking for the H, which is, that's right, it's negative B over 2A. So in this case, I'm going to do the calculation. Good. I'm going to get a positive price. So I've got a negative divided by a negative. That's going to be negative 500 divided by negative 5. So the price is going to be 100. So I answer this with what price will maximize the revenue? A price of $100 will maximize the revenue. Cool. So I'm sure some business people use these formulas. They're probably in their different programs. And of course, I don't know enough about business to really say. And look, here's our last example. Very cool. So we're talking about pumpkin chunkin'. During a pumpkin chunkin' competition last week, okay, probably not, Team Revolution's pumpkin traveled following a trajectory that can be modeled by the following equation. H of t is equal to negative 6t squared plus 42t plus 6, where h is the height of the pumpkin in meters, okay, and t is the time in seconds. So that's why it's not using the negative 16. So how tall was the catapult? How do you know? Well, in this case, if I'm looking for the catapult, right, that's going to tell me when it started. So I'm looking for the y-intercept. I'm imagining it's on the catapult. And then right here's like what a catapult looks like. And then it goes like, it goes like this, right? It goes like ding. And then the pumpkin keeps going until it lands. And then, right? I should have drawn that in orange. So I'm talking about the y-intercept. So in this case, I can see that the y-intercept is just 6 because it's always 0, c. So the catapult was 6 feet tall. When did the pumpkin reach its highest point? So when, we're talking about the x value. Highest point, we're talking about the maximum, which is the vertex. And how do I know? I will calculate it. So I'm looking for the x value of the vertex, which is also known as the h. And so let's do that calculation. H is equal to negative b over 2a. Negative 42 over negative 12. Those don't go in evenly, do they? I'm going to divide the top and bottom by 6. Okay, so when did it reach its highest point? It's going to be after 3.5 seconds. It's kind of a long time. It's going to be in the air for a while. All right, part C, how high did it get? Okay, so how high did it get? I want to answer that with meters. How do I know? I'm going to calculate it. So I'm looking for the y value. Okay, the highest that it got is the maximum that we're again talking about of the vertex. And that's going to be, I'm going to plug in 3.5 to the original equation, so negative 6 times 3.5 squared plus 42 times 3.5 plus 6. And we're going to get our answer in meters. Okay, so I did my calculations and I got 79.5 meters, which is very high. It went very high up in the air. And let's keep going. So you can see I've added in an F. We're going to do that too. So D, when did the pumpkin splatter on the ground? Well, here I'm looking for the x-intercept because that's going to be on the ground, which means it's a height of 0. And so I'm going to need to use either the quadratic formula or factoring. Negative 6, let me write this down again. Negative 6t squared plus 42t plus 6 is equal to 0. So I'm plugging in 0 as the y value. I am going to divide everything by negative 6 to see what answer I get, because I also want to have that lead coefficient be positive in case I can factor this. So it's going to be t squared minus 7t minus 1 is equal to 0. And so I don't see this factoring. I can't think of anything that multiplies to 1 and adds to 7. And completing the square is used when I have an even middle term. So I'm going to use the quadratic formula for this. So it's going to be 7 plus or minus the square root of 49 minus 4 times 1 times negative 1. So I know that inside the radical, I'm going to get a positive number. I'm going to add because I have two negatives. So it's going to be 49 plus 4, which is 53. And all divided by 2. So I'm going to need to use my calculator for this. So we'll need to start, if this is our answer, 7 plus rad 53 over 2. I'm going to ignore the negative because that's going to give me a negative time. The square root of 49 is 7, so if I did 7 minus the square root of 53, the square root of 53 is going to be a little bit bigger than 7. Let's find out exactly how much it is with our calculator. So my calculator says that the square root of 53 is 7 point, and I'm going to round to just one decimal place. This is equal to 7.3 because it was 7.28. And so I'm going to get 7 plus 7.3. I'm going to get 14.3 divided by 2. And that's going to give me 7.15 as my answer. And I'm going to answer that with when? So seconds. So it splatters after 7.15 seconds. I'm going to put my little approximator there to show I rounded this answer. Very cool. Last two are very similar to each other. So in E, the question is, how high was the pumpkin after 1.5 seconds? 1.5 seconds, that's going to be t is equal to 1.5. So here I plug in 1.5 and simplify. So that's going to be negative 6, 1.5 squared, plus 42 times 1.5, and then plus 6. It's going to be negative 6 times 2.25. Plus, so 42 times 1 is 42. plus half of 42. I'm thinking of it like this. Half of 42 is 21. So when I add those together, I get 63. And then plus 6. I need to do this calculation. I think it's going to be a decimal, so I'm not going to try to do it in my head. 2.25 times 6, 13.5. Plus 63, plus 6. I'm going to say that's 19.5 plus 63, which is very similar to 63 plus 20, so 83 minus a 0.5, so 82.5 meters. Oh, shoot, I forgot my negative sign. I better do that again. 82.5 meters, I knew that was wrong because the maximum was 79.5. Hey, we all make mistakes. So let's change that back up. 63, I'll do 63 plus 6, that's 69. And I have negative 13.5. And so, calculator, 55.5 meters high. Cool. Our last problem. So this one is a write-in. It says, when was the pumpkin 50 meters above the ground? Okay, I'm not sure. Let's find out. So 50 meters above the ground, we should get 2 answers for that. I'm imagining it goes like this. It went up to 79.5. So 50 is somewhere down here, and I'm expecting 2 answers. So what we're going to do, 50 meters above the ground, that's a y is equal to 50. And so I'm going to need to do some calculations to get that answer. So let's take a look. I'm going to set the equation equal to 50 and solve. So I've had 50 is equal to negative 6t squared plus 42t plus 6. So to solve this, I have to subtract 50 from both sides. And now I have it equal to 0 so that I can either use factoring or the quadratic formula to solve this. So we've got negative 6t squared plus 42t minus 50 minus 6, 44. And so I'm going to divide to make these numbers smaller because the math will be easier that way. These are all even, but they're not all divisible by 6. I'm going to divide everything by negative 2. In case this factors, I'd like to have a positively coefficient. So it's going to be 3t squared minus 21t plus 22. So if I'm thinking about it, I'm going to think 66 and negative 21. It's going to be 11 and 6. 22 and 3. Those are the only factors. So it's not going to factor. I'm going to need to use the quadratic formula. And it's going to give me 21 plus or minus, I need a calculator. 21 times 21. 441 minus 4 times 3 times 22, all divided by 2a, so 6. Okay, use your calculator to try to get the 2 answers for this. All right, so you can see I did my work over here. This is my radical work, and I got the approximate value 13.3 for that 177 in the radical, and I split it into 2 problems. And then I did the work of adding and then dividing by 6, and I got these 2 answers, approximately 5.7 seconds and 1.3 seconds. So that's all for our notes. We'll see you in class to do our practice problems. I can't wait. Bye.